Welcome to Class 2 in our series on regular expressions. Here in Class 2, we'll build on what we explored during our first class. We'll dive deeper into the fascinating world of regular expressions in Python. You may recall at the end of the first class that we started to explore the match method. And just to refresh ourselves, match checks whether 0 or more characters at the beginning of a string match our pattern. So here, we're going to explore the querying of the match object. Once we use the match object, we can further query to find information out about the matching string. So in our first snippet of code, we see our pattern as A-Z, lowercase, A-Z, uppercase, \S. That's in our character class. And then we have a plus meta character. Then we have the string that we want to match on in the second line of code. And when we fire off the string, we get back a portion of that string. There are many things that is what it matches on. So why does it do this? Let's explore. In our first line of code, our pattern is constructed to grab as many letters, uppercase or lower, and spaces as possible. In our first line of code, we have A lowercase to Z, A uppercase to Z. So that says any letters, uppercase or lowercase, and any spaces, and then the plus. The plus meta character instructs Python to match one or more repetitions of the preceding expression, matching as many repetitions as possible. So it's what we call greedy. Our second line of code is the string we are evaluating the pattern against. So it's in there that we want to find a match. Just as we would expect, the part of the string it matches is all the letters regardless of case and any number of spaces right up until the time we come to our first number. Since numbers are not specified in our pattern, it ends there. If you look at the lower left hand, we'll get to see some of these things that we can extract from using the match method. M represents the string that we'd like to match on. So you see here, m.group, that brings back the portion that matched, just as it did in that last line of code up top. M.start tells us where in the character string we're picking up our very first match, and that's at position 0. And M.end does the same thing in terms of where we end the match. M.end took us through position 27. That's also known as the span. M.span puts those two together. The start, which is 0, the end, which is 27. So methods and attributes that we have using this match method are as follows. The group, which return the string matched by the regular expression, the start position, the end position, and the span, which is a tuple containing the start and end positions. Now we'll explore the search method. So the search method searches a string for the first match of the pattern. It returns a match object on success or none if no match was found. So let's contrast that through the match method that we just learned about. The match method differs from the search method because it checks for 0 or more characters at the beginning of a string. The search method will find the first match anywhere in the string. So let's look at our example here. Our pattern in line 1 of our example says find the first string of 1 or more lowercase letters. The second line is the string we will search on. And you see instead of p.match, it's now p.search. So search, the search method, takes the place of the match method in this example. Why doesn't it find the whole word hey? Because the H is capitalized. And in this particular regular expression pattern, we're just looking for A-Z, all lowercase. So now we can change that, and we want to find the first string of 1 or more letters and ignore the case. And remember, we can use that method ignore case, re.I. You see that at the end of our pattern in the first line in the second snippet of code. Everything else stays the same, and now our search returns hey instead of A, including both lowercase and uppercase letters. Here just a bit more on the search method. We're doing virtually the same thing here as we did on the previous page with a few exceptions. We're using an if statement for flow control. If m Also notice how we're using group here with the search method instead of with the match method. So you see that group works with both of them. You see how we have group embedded right into our print statement here. We just wanted to give you exposure to another way of doing things. So welcome to the wonderful world of word boundary. So here we have \b. This is a zero width assertion that matches only at the beginning and end of a word. A word is defined as a sequence of alphanumeric characters. So the end of the word is indicated by white space or a non-alphanumeric character. So let's look at our code. Here we have the word pizza surrounded on both ends by the /b. We're searching on the phrase, I want a pizza pie, all one word. And you see that it comes back with none. But in the second example, we change our search text to I want a pizza. And you see it does indeed match. The second example matches pizza only because it's a complete word. It won't match when it's contained inside another word, as is the case in the first example, because there are no boundaries that meet the requirement. Okay, let's look at another word boundary, another zero width assertion. This is the opposite of \lowercase b. It is \uppercase b, and it only matches when the current position is not at a word boundary. So it's the exact opposite of what we just looked at. So let's look at our code. We have p equals re.compile our pizza surrounded by the \b at its front and end. Same exact example as from our previous slide, only with the uppercase b. Now we search I want pizza and we get none. We then try I want pizza pie and we still get none. The condition is not satisfied. There is a boundary that is space or alphanumeric. Now we try one that we do expect to match. Do you think pineapple pizza pies taste good? And you see pizza, the word pizza is embedded in pineapple pizza pies. So exactly then do we get the match. So if the word pizza is a word boundary like in pizza, pizza pie, or cheese pizza, it will not match. But when it's embedded inside a string, it will find it. The match will succeed. And that's what we just saw. This concludes class 2 of regular expressions in Python. We have 2 more to go. We get more and more complex and more involved as we go. So I think you'll be excited about the things that we bring you in the last 2 modules. So please stay with us and we'll see you in the next one.